I think the first thing we want to do is mill off the end so that it's short, and then our other operations don't have to take that material off. Now we want to cut it to what's the silhouette. Remember, this was not supposed to be spherical. So if to this tip it's the correct distance. They've included a tool within HSM for that. They've got a couple tools here that help you with that. So here we have these two utilities that create a sketch. And there's the create spun profile. So if you needed a profile to follow, you could do that based off a revolved shape. It doesn't work very well unless it's a fully revolved. Or there's create silhouette. So what we want to do is we want to create a silhouette sketch that will pick up on the edge of the silhouette of this part in the orientation of the view that's slicing right through it. So that would be the top plane. So if we select the model, create the top plane, we're going to do a silhouette of the model, and we're going to accept that. And we now have this new sketch here that has this arc on it is what we need. We don't need the other pieces of it. So we could go in and delete those features on that sketch, or there's a way just to select that edge. We're done with that sketch. We're going to go back to CAM, and we're going to do a 2D milling, 2D contour move. Okay, we're going to go to our library and we're going to select from the mill library our 1/8 inch flat end mill. You could use a 3/8, but this is such a small part. Look how big the cutter is. In general, if your part is smaller than your end mill, you're going to put a lot of torque on that surface and could rip it out of the fixture. Okay, again, our cutting feed is a little fast for this small of a scale of part, so we're going to drop that to 20. We can leave the others at 13. That's fine. We're going to go to geometry, and here's where we're going to select our sketch. We're going to pick the sketch element, and that's what we're actually going to follow. We're not going to follow the whole thing. Okay, and we can add extensions. We want to add extensions to this because we want it to machine off the part to get to it. So let's put in a tangential extension of half the diameter of our cutter. Round it up a little bit. So our cutter is an 1/8 inch. Half its diameter would be 62 thousandths. So let's put in 0.065, and that will extend this arc in both directions. Okay, we're going to go to heights. Okay, we're going to leave all this at default, but our stock top is good for the top of the cut, but we're not cutting to the contour. We're going to cut all the way through, because right now we have a full rod. This flat doesn't exist yet. So we're going to go to stock. Model bottom will work, either stock or model, because it's semantics, it's the same. Okay, so it goes down to this blue plane. Now we want to make sure we cut all the way past. We don't want to leave a little bit of a tang of material that our slot cutter might hit. So let's go negative 0.01. So we'll go about 10 thousandths deeper just to make sure if there's any cutter mismatch in setting cutters. Now we're assuming this is being held in a chuck, and so that there's air underneath the rod. We're not going to hit any fixtures, but it'd be important to set it up that way. Okay, we're going to go to our cutting tab. We're going to do wear compensation. We're going to do roughing passes. Okay, so we're going to do a finishing pass. Right now it's set to 12 thousandths. Then we're going to do roughing passes. We can leave the roughing pass where it's at. And since we're only doing one, it's somewhat academic. All right, and then we're going to go to multiple depths. And our rod's 197 thousandths in diameter. Let's go half the cutter diameter. So it's 1/8 inch diameter. We're going to do a 1/16 steps. We're not going to do any finish passes on the bottom, and then we're going to finish the side only at final depth, because our cutter should be plenty big enough to do that, and it's only taking 12 thousandths off. Let's actually change that to 10 thou for that final cut where it's doing a full flute. And then we're going to use even step downs. We want to turn on smoothing because it is cutting an arc. Okay, we're going to go to the next tab. And I don't think we want to keep the tool down. That's a good way to break it in this context. So we want it to force it to retract and pick up and go to the other side. Lead in radius, not that critical on this. It's already an arc, we're leading in off tangentially. So let's put 0 on the lead in arc. We're going to come in at 0 degrees angle. And we currently have a 12 thousandths lead in. Let's bump that up to half the diameter plus. So 0.06, 0.63. And our lead out is going to be the same as the lead in. Okay, let's accept that and see what this looks like. All right, so we've got a lead in straight in, and then we've got a tangential extension. That's for half the diameter of the cutter. It cuts our arc, leads back out. So we need to make sure that, you know, we're free of any fixtures that may get in the way of this part. And the reason it's picking up this yellow plane is I deselected that 2-inch. It's because of the scale of this part. If you were doing a much larger part, you'd force the cutter to stay down. Okay, so that's the cut on the end. Now we want to do the flats. Now you could cut that with an end mill, flip the part over 180 degrees, cut it with an end mill on the opposite side. We are using a slot mill on this in our library, so we could cut this in one setup with a slot mill. So let's do a little evaluation here. If we were to evaluate the distance between here and here, it's about 700 thousandths. Let's bump up our precision. Okay, it's 670 thousandths. Our slot mill is 16th, so it's 62 thousandths, 5/10. So we need to take more than one pass at this. Now, on the top, it's relatively straightforward. We cut this at line, we can do a couple steps. On the opposite side, typically you're going to want to cut actually in reverse. You're going to do a rough cut and you do a final finish cut that's going to be higher. There's not really a good way to program that. So what we're going to do is we're going to have to take a adjusted version of our cut on the top piece and do a translate down in Z. What does that mean? Here we go. We're going to go contour milling, 2D milling. We're going to do a 2D contour. Okay, and we're going to switch to mill tools, and we're going to use the... Okay, so we're using this slot mill, and it's a 16th high here, but it's 1.25 inches in diameter, so it's a pretty big end mill in the scale of this part. Like 40 inches a minute is fine for soft material. This thing has a lot of teeth on it, so it can go along pretty quick. It's at 2,000 RPM because it has such a large diameter and lots of teeth. What are we cutting? We're going to cut this line here, and we don't want it to, we don't want propagate along Z. We just want that one line. And now we want to put an extension in both directions of half the diameter of the cutter. So it's an 1¼ inch cutter divided by 2 gives us 625 thousandths. That makes sure that we're starting off the workpiece. Okay, we're going to go to heights. Okay, we're going to leave all of this at default, and we're going to go to the contour in this case. We're going to use wear compensation. We do want to go, okay, and our finish pass is not going to be an 1/8 inch. We're going to go 20 thousandths. Okay, and our roughing passes, we're not going an inch and 175 thousandths is our roughing pass. Let's go 0.2. We're only going to do 1. We are going to do multiple depths in this case. And we want to finish at each step down with this type of cutter because it's not spanning the entire face. We're going to use even step downs. We're going to put 0 under finish passes. We're going to go to the next tab. We don't want to keep the tool down. We want it to lift up. We don't need a lead-in arc. And we definitely don't want a vertical lead-in arc on a saw. It will break it. And then we're going to come in at 0 degrees. And 1/8 inch lead-in should be enough because we've done the tangential extensions. And we'll have the lead out match it. All right, let's hit accept. Okay, so we have our 2 rough and 2 finish passes. We should clean that up quite well. Okay, now on the opposite side, we actually want our first cut to be lower than the second cut. So we're not going to be able to achieve that with the same exact method because this is going to go from the top to the other. I don't think there's a way we can change the order. So what we're going to do is we're going to duplicate this tool path. Then we're going to edit the tool path. And what we're going to do is we're going to go to this page here. And we're going to deselect the multiple depths. So everything's going to stay the same. Except for we're doing just 1 rough and 1 finish pass horizontally. Then we're going to go to our depths here. And we've selected this line as what we're cutting to. And we want to shift this down by the thickness of the tab and the thickness of the cutter plus some extra material. So if we're going to take, say, half of this off, we need to add that to our negative number. So we're going to go from contour and we're going to start off with negative 1/16. Okay, and then minus another 1/16. Okay, so that gets our cutter down, and that would be our final finish pass. Okay, and then let's play that. And we get our single cut. Okay, so that would be doing our finish cut. Now let's duplicate that. Okay, so contour 4 will be our finish pass. And we want to do a rough cut that's deeper than that. That takes off about half the material that we have there. So we're going to go edit. We want this lower by about 20 thousandths because that was what our rough step over was. So we're going to go to negative 145 instead of 25 and hit accept. All right, so our first cut is lower, and then our final cut is higher. and so it's actually finishing the lower face. A little bit hard to conceive, but you want to be cutting the lower face last, so it's skimming off just a little bit off that face. Unfortunately, there's no, on the lathe you can say I want to cut backwards. On the mill it doesn't allow you to do that. Alright, so we have one more feature to make, and that's the cross drilled hole. That's going to use 2 drill bits. We're going to start off using our spot drill, but you want to make sure you pick it from the mill library. It's in a different position, and it has the change setting which says live tool, which will output the spindle on command when you select it. So if you have it in the lathe mode, it won't put out the correct code, and it'll probably give you an error when you post-process. Alright, let's slow our cutting rate down to 20 inches a minute. Okay, and then we're going to go to our feature. We're drilling this hole here. Our heights. Okay, stock top's fine. We are going from the top of the hole, and then we're actually going to go to hole top again, because we're going to calculate and manually type in how deep this drill goes. So if we look at our drawing, that hole is, its maximum tolerance is 65 thousandths. So we want to go negative bracket 0.065 plus 0.01 close bracket divided by 2. So that gives us half diameter with an extra 10 thousandths of depth. Okay, should be negative 37 thousandths 5/10. We'll accept that. Okay, we should have our cut in. And now we're going to come in with our drill and then a reamer. So we go to drill, and we're going to go to our library. We make sure you're going to the mill tools, and we're looking for the drill bit that's going to precede our reamer. Our tolerance is 63 thousandths to 65, so I believe that's a 64 reamer we're going to use. And the drill bit we chose to precede that reamer with was the 55 thousandths drill, or the number 54 drill. We're going to select that. We're going to change our feed rates to 9 and 9. 13 is a little fast for that small of a cutter. And we've got our hole. We're going to select the hole there. Then we're going to go to heights. And stock top's fine. We want to go from top. We're going to go from hole top. We want to go to the hole bottom. We want the drill point to break through. And we're going to go negative 0.01, a little bit deeper, just to make sure. And negative point, or we're going to go 0.01. Okay, in our last tab, we're going to select deep drilling, full retract. And our peck depth, we're going to set it as half the diameter of the cutter. So 0.055 divided by 2 gives us 227 thousandths 5/10 peck. And we're going to just leave it at that. We hit OK. Now we're going to come back with our reamer. Okay, so we're going to go back to drilling. You're going to go to your library. You go to mill tools. And we're going to select our 64 thousandths reamer. I think 40 inches a minute's a little fast, so again, let's lower the feed rate on that to 13 inches a minute on that. Go to geometry, we select our hole. We go to the next tab. We're going to keep everything at default except for we need to go deeper because the reamer has a chamfer on the end. So let's go negative 0.03. If you actually have the tool, you can measure the chamfer size, and but you want to go a little bit deeper so that the hole is the same size all the way through. It doesn't really have a drill tip to calculate. And then we're going to go to the next tab. And yes, we want reaming. Okay, let's simulate and see what we've done so far. I'm going to collapse down both programs. Okay, so we're going to stock simulate it. When you're switching from mill to lathe, it doesn't really go back to back like it should. So we'll just keep that in mind. Here we go, stock simulation. Okay, we're going to face. We spot drill. We're coming in and peck drilling the end. Turning the outside of the part. Coming in, parting off. Okay, and then we go to the mill side of things. We're coming in and we're milling off the end, an arc shape. Now it's coming in with the slot mill. Okay, we came in with the spot drill. Now we're coming in with the drill bit that's prior to the reamer. Let's change position so you can see a little bit better. It's doing its pecks. And now it's retracting. It switches tools to the reamer. The reamer comes in, does its deal, and we're done. There we go. So we have 2 setup sheets and 2 programs you need to submit with this project. Catch you on the next one.